Close your eyes for a moment and imagine standing on a quiet beach at sunrise. The horizon stretches in every direction, cities lie beyond mountains, oceans cover most of the planet, and billions of people are living their lives at this very moment. Earth feels enormous. It has deserts that take days to cross, mountain ranges that stretch for thousands of kilometers, and oceans so vast that early explorers believed they had reached the edge of the world. For almost all of human history, our planet seemed limitless. Yet everything you have ever known exists on a surprisingly small sphere floating through an unimaginably larger universe. Earth measures about 12,742 kilometers across. That sounds immense, and by everyday standards it certainly is. Walking around the planet would take years. Flying from one side to the other takes more than half a day. Even light, the fastest thing in the universe traveling at nearly 300,000 kilometers every second, still needs over 4/100ths of a second to cross Earth from one side to the other. Compared to our daily lives, Earth is massive. But our perspective begins to change the moment we leave the ground. From just a few hundred kilometers above the surface, astronauts aboard the International Space Station see the entire horizon curve beneath them. Continents no longer seem endless. Borders disappear completely. Cities become invisible. The entire civilization that humans have spent thousands of years building is reduced to an incredibly thin layer wrapped around a blue sphere. And that sphere itself has a surprisingly delicate skin. If Earth were the size of an apple, the atmosphere, the very air that keeps every plant, animal, and person alive, would be thinner than the apple's skin. Almost everything that has ever lived exists inside this fragile shell, only a few dozen kilometers thick. Above it lies the vacuum of space, where there is no air to breathe, no sound to hear, and no protection from the harsh radiation of the sun. Even Earth's motion is something we rarely notice. Right now, although you feel perfectly still, you are spinning with the planet at up to 1,670 kilometers per hour near the equator. At the same time, Earth is racing around the sun at nearly 108,000 kilometers per hour. Our entire solar system is orbiting the center of the Milky Way at roughly 828,000 kilometers per hour. None of this motion is noticeable because everything around us is moving together, yet every second we travel millions of kilometers through space without realizing it. Then there is our closest neighbor, the Moon. Looking up at the night sky, the Moon appears almost close enough to touch. It dominates our evenings, controls the tides, and has inspired myths and exploration for thousands of years. But appearances can be deceptive. The Moon is nearly 385,000 kilometers away. Light takes about 1¼ seconds to travel from the Moon to Earth. The astronauts of Apollo needed roughly 3 days to make the journey. That distance alone is extraordinary, yet compared to what comes next, it is almost insignificant. Now imagine placing Earth beside Jupiter. Suddenly our planet looks tiny. More than 1,300 Earths could fit inside Jupiter. Its storms are larger than our entire world, and its magnetic field is so powerful that it traps intense radiation across millions of kilometers. But even Jupiter is dwarfed by the object that dominates our solar system. The Sun contains over 99.8% of all the mass in the solar system. More than 1 million Earths could fit inside it. If Earth were the size of a marble, the Sun would be nearly the size of a 2-story house. Every second, the Sun converts about 600 million tons of hydrogen into helium, releasing enough energy to power our civilization billions of times over. Despite its incredible size, the Sun is not considered a particularly large star. In fact, astronomers classify it as an ordinary yellow dwarf, one of hundreds of billions of stars in our galaxy. That realization changes everything. The giant star that dominates our sky, warms our planet, and makes life possible is simply average. And if our Sun is only average, then how large is the universe that contains it? To answer that question, we first have to understand just how empty our own neighborhood really is. Every picture you've ever seen of the solar system has lied to you. Not intentionally, of course. If textbooks drew the planets at their true distances, the page would need to be several meters long just to show the inner planets, and Neptune would disappear somewhere far beyond the edge of the book. To fit everything into a single image, every diagram compresses the distances. As a result, most of us grow up believing the planets are relatively close together. The reality is far more astonishing. Imagine shrinking the Sun until it is exactly 1 meter in diameter. At that scale, Mercury would be a tiny speck over 40 meters away. Venus would orbit at roughly 75 meters. Earth would be a marble about 109 meters from the Sun, while Mars would circle nearly 170 meters away. Even this small section already requires the length of a football field. Then the emptiness begins. Jupiter, the largest planet in the solar system, would orbit more than half a kilometer away. Saturn would be nearly 1 kilometer from the Sun. Uranus would be almost 2 kilometers away, and Neptune nearly 3 kilometers away. Between these worlds lies almost nothing, just an enormous vacuum occasionally interrupted by small rocks, dust, or icy objects. Space is not crowded. Space is almost completely empty. This is why traveling between planets is so difficult. Light reaches the Moon in just over 1 second, but it needs more than 8 minutes to travel from the Sun to Earth. A radio signal sent from Earth to Mars can take anywhere between 3 and over 20 minutes depending on where the planets are in their orbits. Communicating with spacecraft exploring the outer planets becomes an exercise in patience, with signals taking hours to cross the vast distances. Human spacecraft are even slower. The Apollo astronauts reached the Moon in about 3 days. The Parker Solar Probe, the fastest spacecraft ever built, has exceeded 690,000 kilometers per hour while flying close to the Sun. Even at those incredible speeds, crossing the entire solar system still takes years. Perhaps no mission illustrates this better than Voyager 1. Launched in 1977, Voyager 1 has been traveling for nearly half a century. It has flown past Jupiter and Saturn, crossed the boundary where the Sun's influence begins to fade, and entered interstellar space. It is now the most distant human-made object ever created, more than 25 billion kilometers from Earth. That sounds impossibly far. Yet Voyager has not even come close to leaving the solar system. Beyond Neptune lies the Kuiper Belt, a vast region filled with icy worlds, including Pluto. Far beyond that is the scattered disk, where frozen objects follow highly elongated orbits. And surrounding everything is the Oort cloud, an enormous spherical shell of icy bodies thought to extend perhaps 100,000 times farther from the Sun than Earth does. If the orbit of Neptune were reduced to the width of a coin, the Oort cloud could still stretch for several kilometers in every direction. The solar system is far larger than most people imagine. And then comes the most surprising realization of all. Even after crossing the Oort cloud, after leaving every planet, asteroid, comet, and icy world behind, you still have not reached another star. You have simply entered an even larger ocean of empty space. Our nearest stellar neighbor, Alpha Centauri, is so unimaginably distant that the entire solar system occupies only a tiny fraction of the journey. The vast emptiness we experience between the planets is merely the beginning. Between stars, the distances become almost impossible for the human mind to comprehend. To truly understand the size of the universe, we must leave the solar system behind and venture into the darkness between the stars. If the solar system feels unimaginably large, then what lies beyond it almost defies human comprehension. For thousands of years, the stars looked like tiny points of light attached to a celestial sphere surrounding Earth. Ancient civilizations drew constellations, navigated by them, and built entire mythologies around their patterns. But those familiar shapes hide an extraordinary truth. The stars in a constellation are usually nowhere near each other. They only appear grouped together because of our viewpoint from Earth. In reality, they are separated by enormous distances across the galaxy. Once we leave the edge of the solar system, we enter what astronomers call interstellar space. It is an ocean so vast and empty that our nearest neighboring star is still incredibly far away. That nearest star system is Alpha Centauri, located about 4.37 light-years from Earth. A light-year is not a measure of time but of distance. It is the distance that light travels in 1 year, about 9.46 trillion kilometers. Since light moves at nearly 300,000 kilometers every second, a single light-year represents one of the largest distances we commonly use in astronomy. Imagine turning on a flashlight powerful enough to shine all the way to Alpha Centauri. The beam would leave Earth today and would not arrive until more than 4 years later. Even light, the fastest thing the universe allows, needs over 4 years to make the journey. Now compare that to human technology. A commercial airliner traveling around 900 kilometers per hour would need well over 5 million years to reach Alpha Centauri. The Apollo spacecraft that carried astronauts to the moon would take hundreds of thousands of years. Even Voyager 1, the fastest object ever sent into deep space for such a long journey, would require more than 70,000 years to arrive. Our fastest spacecraft has not even traveled 1% of the distance to the nearest star. This is why scientists often say that interstellar travel is one of humanity's greatest engineering challenges. The distances are so enormous that they redefine our understanding of time itself. A journey between stars cannot simply last months or years. It may span generations. One of the best ways to understand this scale is through a simple comparison. Imagine shrinking the Sun until it becomes the size of a basketball. Earth would be a tiny grain of sand orbiting about 26 meters away. Neptune would circle nearly 800 meters from the basketball. The entire solar system would comfortably fit inside a large city park. But where would Alpha Centauri be? Not in the next park. Not in the next city. It would be located roughly 7,000 kilometers away, the distance from New York to London, or from Cairo to Beijing. Everything inside our solar system would occupy one small park. The nearest star would be on another continent. And between them, almost nothing. Interstellar space is not completely empty. It contains a few atoms, tiny dust particles, magnetic fields, and cosmic rays, but the average density is astonishingly low. A single cubic centimeter of this space may contain just one atom. Compared to the air you are breathing right now, it is a vacuum beyond anything we can produce on Earth. The farther we look, the stranger the universe becomes. Many of the stars we see tonight are dozens, hundreds, or even thousands of light years away. Their light began traveling toward Earth long before modern civilization existed. Some of the distant stars visible through powerful telescopes may no longer exist at all. Their final explosions could have already happened, but the news is still crossing the immense darkness between us. Looking into space is literally looking into the past. Every telescope is also a time machine. As we continue moving farther away from the solar system, individual stars slowly become too numerous to count. They begin merging into vast rivers of light stretching across the night sky. That glowing river has a name. It is our home galaxy. And compared to what lies inside it, even the distance between stars is only the beginning. On a clear night, far away from city lights, you may notice a faint band of white stretching across the sky. It looks like a cloud, almost like someone brushed a streak of milk across the darkness. Ancient civilizations called it the Milky Way. For centuries, no one knew what it really was. Today, we know something astonishing. That glowing band is not a cloud. It is the combined light of hundreds of billions of stars, all belonging to the galaxy we call home. The Milky Way is an enormous, spiral galaxy measuring roughly 100,000 light-years across. To appreciate that number, remember that light reaches the Moon in just over 1 second and travels from the Sun to Earth in 8 minutes. Yet crossing our galaxy takes light about 100,000 years. If a beam of light began its journey when early humans were painting on cave walls, it still would not have reached the opposite side of the Milky Way today. Some estimates suggest our galaxy contains between 100 and 400 billion stars. Many of those stars have planets of their own, and recent discoveries suggest that planets may actually outnumber the stars themselves. This means our galaxy alone could contain hundreds of billions, or even trillions of worlds. Some may be barren deserts. Some may be covered by oceans. Some may resemble Earth. And somewhere among those hundreds of billions of stars is our own Sun. Finding our solar system inside the Milky Way is like trying to locate a single grain of sand on an entire beach. We are not near the center of the galaxy, nor are we close to its edge. Instead, the Sun quietly orbits within one of the spiral arms about 26,000 light-years from the galactic center. That journey around the center is far from slow. Our solar system travels at nearly 828,000 kilometers per hour, yet the Milky Way is so enormous that completing one orbit takes about 230 million years. The last time Earth occupied this exact position in the galaxy, dinosaurs had not yet appeared. Entire continents looked different, and mammals were only beginning their long evolutionary story. At the center of the Milky Way lies one of the most mysterious objects in the universe, a supermassive black hole known as Sagittarius A. It contains the mass of about 4 million suns compressed into a region smaller than the orbit of Mercury. Although invisible, astronomers have tracked nearby stars racing around an apparently empty point in space, revealing the black hole's immense gravitational pull. Fortunately, we are far enough away that it poses no danger to Earth. In fact, the black hole is so distant that its gravity influences us no more than the rest of the galaxy. As our telescopes improved, astronomers made another incredible discovery. The Milky Way is not alone. For centuries, many believed our galaxy was the entire universe. Then, in the early 20th century, observations revealed that faint spiral smudges seen through telescopes were not clouds inside the Milky Way at all. They were entirely separate galaxies, each containing hundreds of billions of stars of their own. Suddenly, our galaxy changed from being the universe to being just one island in a much larger cosmic ocean. And if one galaxy can contain hundreds of billions of stars, how many galaxies exist across the universe? The answer is far greater than anyone imagined, and it will take us beyond the boundaries of our own galaxy into a universe filled with countless others. By now, we've traveled from Earth to the edge of our solar system, crossed the unimaginable darkness between the stars, and discovered that our Sun is just one ordinary star inside the Milky Way. It already feels as though we've reached an extraordinary scale. But we've barely left home. The nearest major galaxy to the Milky Way is the Andromeda Galaxy, located about 2.5 million light-years away. That means the light reaching your eyes today began its journey long before the first humans appeared on Earth. When that light left Andromeda, our ancient ancestors were still early members of the genus Homo, using simple stone tools while completely unaware of the vast universe surrounding them. Andromeda is even larger than the Milky Way. It contains roughly 1 trillion stars, perhaps 2 or 3 times as many as our own galaxy. If our entire solar system vanished tomorrow, Andromeda would never notice. Even if the entire Milky Way disappeared, the universe itself would barely change. Despite the enormous distance between them, the Milky Way and Andromeda are moving toward one another at about 400,000 kilometers per hour. At first, that sounds alarmingly fast. But because space is so unimaginably large, the collision won't happen for another 4 to 5 billion years. Even then, the word collision is somewhat misleading. Galaxies are mostly empty space. Although each galaxy contains hundreds of billions of stars, the distances between those stars are so vast that when the Milky Way and Andromeda merge, it is extremely unlikely that even a single pair of stars will collide directly. Instead, gravity will slowly reshape both galaxies over billions of years until they become one enormous elliptical galaxy. Our galaxy is not isolated. Along with Andromeda, the smaller Triangulum galaxy, and dozens of dwarf galaxies, it belongs to a family known as the Local Group. This region stretches across roughly 10 million light-years and contains more than 80 known galaxies, all gravitationally connected despite the tremendous distances separating them. But the Local Group is only one neighborhood. Beyond it lies the Virgo cluster, containing more than 1,000 galaxies. Beyond that are even larger collections called superclusters, where tens of thousands of galaxies gather into enormous cosmic structures. One of these is the Laniakea supercluster, the immense region of space that contains the Milky Way. Laniakea spans more than 500 million light-years and contains approximately 100,000 galaxies. Trying to imagine that number is nearly impossible. If every galaxy were reduced to a grain of sand, Laniakea alone would fill an entire beach. Yet even that is not the largest structure in the universe. As astronomers mapped millions of galaxies, they noticed something extraordinary. Galaxies are not distributed randomly through space. Instead, they form gigantic filaments stretching across hundreds of millions of light-years. These filaments intersect like threads in an unimaginably vast three-dimensional web. Between them lie enormous voids where almost no galaxies exist. This structure is known as the cosmic web. Looking at it from afar, it resembles the network of neurons inside a human brain or the strands of a spider's web glistening with dew. Although the resemblance is only visual and not physical, it is one of the most breathtaking patterns ever discovered in nature. Every bright point within this web is not a star. It is an entire galaxy. Every galaxy contains hundreds of billions of stars. Many of those stars have planets. Many of those planets may have moons. Some may even have life. The numbers become so enormous that ordinary language begins to lose its meaning. For centuries, people wondered whether the Milky Way was the entire universe. Today, we know that it is only one galaxy among perhaps hundreds of billions, and possibly even trillions, spread across the observable cosmos. And that realization raises an even bigger question. If galaxies fill the universe in every direction, just how large is the universe itself? To answer that, we must travel farther than light has had time to cross since the birth of the cosmos. If you could travel forever in one direction, would you eventually reach the edge of the universe? It sounds like a simple question, but the answer is one of the most surprising discoveries in modern cosmology. Everything we've explored so far, the Earth, the solar system, the Milky Way, neighboring galaxies, clusters and superclusters, exists within something astronomers call the observable universe. This is not the entire universe. It is simply the portion from which light has had enough time to reach us since the universe began approximately 13.8 billion years ago. At first glance, you might expect the observable universe to have a radius of 13.8 billion light-years. It doesn't. Instead, it extends about 46.5 billion light-years in every direction, making it roughly 93 billion light-years across. How is that possible? How can we observe something farther away than the age of the universe would seem to allow? The answer is that space itself has been expanding ever since the Big Bang. A common misunderstanding is to imagine the Big Bang as an explosion that threw galaxies outward into empty space. But that isn't what happened. The galaxies are not flying through space like fragments from an explosion. Instead, space itself is stretching. Every region of the universe is expanding away from every other region, carrying galaxies along like raisins embedded inside rising bread dough. As the dough expands, every raisin moves farther from every other raisin, not because the raisins are moving on their own, but because the dough between them is growing. The universe behaves in much the same way. Imagine a photon of light beginning its journey toward Earth nearly 13.5 billion years ago. While that photon was traveling, the universe continued expanding. The galaxy that emitted the light did not remain where it started. It was carried farther and farther away by the expansion of space. As a result, although the light took 13.5 billion years to reach us, the galaxy that emitted it is now tens of billions of light-years away. This is why the observable universe is much larger than its age might suggest. As telescopes became more powerful, humanity pushed deeper into this cosmic horizon. The Hubble Space Telescope revealed thousands of distant galaxies in tiny patches of seemingly empty sky. The James Webb Space Telescope has looked even farther back in time, revealing galaxies that formed only a few 100 million years after the Big Bang. Every improvement in technology has shown us the same thing. The universe is larger than we expected. Again and again. There is also a profound limit to what we can ever observe. Beyond a certain distance, the expansion of space is carrying galaxies away so rapidly that their future light will never reach Earth. This does not violate Einstein's theory of relativity because the galaxies are not moving through space faster than light. Instead, the space between us is expanding. Those galaxies are effectively disappearing from our reachable universe. Future civilizations, living trillions of years from now, may never know they existed. As the expansion continues, more and more galaxies will slip beyond the cosmic horizon, leaving only our local group visible in the distant future. In a sense, the universe is slowly becoming lonelier. Today, astronomers estimate that the observable universe contains hundreds of billions of galaxies. Some recent studies suggest the true number may even approach 2 trillion when accounting for galaxies too faint or distant for our current telescopes to detect. Regardless of the exact count, the number of stars almost certainly exceeds the total number of grains of sand on every beach on Earth. And yet, after everything we've seen, one astonishing fact remains. The observable universe is not necessarily the entire universe. It is simply the part we can see. Beyond that cosmic horizon may lie vastly more space, perhaps infinitely more, hidden forever from our view. And that is where our journey takes its most fascinating turn. Everything we've explored so far exists within the observable universe, the part of the cosmos that light has had enough time to reveal to us. It is the largest map humanity has ever created, stretching approximately 93 billion light-years across. But what lies beyond it? The honest answer is both fascinating and frustrating. We don't know. This is one of the few questions in science where even our greatest telescopes cannot provide a direct answer. The observable universe is not a physical wall or the edge of existence. It is simply the limit of what information has been able to reach us since the beginning of the universe. Beyond that horizon, light has not yet had enough time to arrive, meaning those regions remain forever hidden, at least for now. Imagine standing on a hill overlooking the ocean. On a clear day, you can see all the way to the horizon. It may appear as though the world ends there, but you know it doesn't. Ships continue sailing beyond your view, hidden only because the Earth curves away beneath them. The observable universe is similar. The horizon exists because of the limits of observation, not because reality suddenly stops. So what might exist beyond it? One possibility is surprisingly simple. The universe beyond our horizon may look almost identical to the part we can see. Galaxies, stars, planets, and immense cosmic webs could continue in every direction for unimaginable distances. If this is true, then the observable universe is only a tiny bubble inside something vastly larger. Some cosmologists even believe the universe may be infinite. An infinite universe is difficult for the human mind to grasp. If space truly extends forever, then there would be no edge to reach, no final galaxy, and no last destination. You could travel for trillions upon trillions of years and still never encounter a boundary. Infinity is not just extremely large. It has no end at all. Another possibility is that the universe is finite but unbounded. This sounds contradictory, but it isn't. Consider the surface of Earth. You can walk in one direction forever without ever reaching an edge, eventually returning to where you started. Earth's surface is finite in area, yet it has no boundary. Some scientists suggest that the universe could behave in a similar way, except in 3 dimensions rather than 2. Current observations indicate that if space is curved at all, that curvature is incredibly small. On the scales we can measure, the universe appears remarkably flat. Whether it continues forever or eventually wraps around itself remains one of cosmology's greatest unanswered questions. Then there is an even more extraordinary idea. During the first tiny fraction of a second after the Big Bang, the universe may have undergone an event known as cosmic inflation. Space itself expanded at an astonishing rate, growing from something smaller than an atom to astronomical sizes almost instantly. According to some versions of this theory, inflation may never have completely stopped. Instead, it could still be happening. If that is true, then our observable universe might be only one bubble inside an unimaginably larger cosmic landscape. Elsewhere, other bubble universes could exist, each forever separated from the others by expanding space. This idea often leads to discussions of the multiverse. It is important to make one distinction very clear. Cosmic inflation is supported by strong observational evidence, and is considered a central part of modern cosmology. The multiverse, however, is still a theoretical possibility. While some models naturally predict it, there is currently no direct observational evidence proving that other universes exist. Science draws a careful line between what has been observed and what remains a hypothesis. That uncertainty does not make the question less exciting. In many ways, it makes it even more profound. For thousands of years, every time humanity believed it had discovered the edge of the world, a larger world was waiting beyond it. The edge of the Earth became the solar system. The solar system became the Milky Way. The Milky Way became one galaxy among billions. Perhaps one day, even the observable universe will become just another small part of a much larger reality. But before we ask what exists beyond the universe, we should ask an equally astonishing question. How much time has passed while all of this has unfolded? Understanding the universe isn't only about understanding distance. It is also about understanding time. The numbers we've encountered throughout this journey are almost impossible to imagine. Millions of light years. Billions of stars. Trillions of kilometers. Yet there is another number just as difficult to comprehend. The universe is approximately 13.8 billion years old. That number is so enormous that our brains struggle to visualize it. One of the best ways to understand it is to compress the entire history of the universe into a single calendar year. Imagine that midnight on January 1st marks the Big Bang. In the first tiny fraction of a second, the universe expands dramatically during cosmic inflation. Within minutes, the first atomic nuclei begin to form. Then the universe enters a long period of darkness. There are no stars, no galaxies, and no planets, only a hot, expanding sea of particles gradually cooling over hundreds of millions of years. Around the middle of January, the first stars ignite. These stars are unlike the ones we see today. They are enormous, incredibly bright, and live only short lives before exploding as supernovae. In their violent deaths, they create many of the heavier elements that will eventually become planets and living organisms. By March, the first galaxies begin to take shape. For billions of years, galaxies grow larger through gravity, merging with one another and forming the immense cosmic structures we observe today. During this vast stretch of time, there is still no Earth, no Sun, and certainly no life. Our solar system does not appear until early September. Nearly two-thirds of the universe's history has already passed before our Sun is born. Shortly afterward, Earth forms from a swirling disk of gas and dust surrounding the young Sun. At first, it is a molten world constantly bombarded by asteroids. Gradually, the surface cools. Oceans begin to form. The conditions for life slowly emerge. Around the middle of September, the earliest simple life appears. For months on our cosmic calendar, life remains microscopic. Single-celled organisms dominate Earth while the universe continues its slow evolution around them. Complex life finally begins to flourish in December. Dinosaurs appear on December 25th. They rule Earth for several days before disappearing on December 30th after the asteroid impact that forever changes our planet. Modern humans arrive astonishingly late. If the universe's history were one calendar year, the first members of our species would appear just before midnight on December 31st. Agriculture begins only during the final minute. The pyramids are built with roughly 50 seconds remaining. The Roman Empire rises and falls in the last 20 seconds. The Industrial Revolution occupies about the final 2 seconds. Everything you have ever learned in school, every civilization, every empire, every war, every invention, every scientific discovery, every human who has ever lived, all of recorded history fits comfortably within the final heartbeat of the cosmic year. This perspective is both humbling and inspiring. Humanity is incredibly young compared to the universe. Yet within this tiny fraction of cosmic time, we have learned to build telescopes capable of seeing galaxies billions of light years away. We have landed on another world, sent spacecraft beyond the solar system, photographed a black hole, and measured the age of the universe itself. The universe did not wait for us. We arrived almost at the very end of the calendar. And somehow, in that brief moment, we became capable of asking questions about the entire cosmos. Perhaps that is what makes humanity remarkable. Not our size, not our age, but our curiosity. And in our final chapter, we'll bring together everything we've learned, from the Earth beneath our feet to the edge of the observable universe, and ask the biggest question of all. Just how small are we, really? Take a moment to think back to where this journey began. We started on a single planet orbiting an ordinary star. That star turned out to be one of hundreds of billions inside the Milky Way. The Milky Way became one galaxy among billions. Those galaxies formed clusters. Those clusters formed superclusters. Those superclusters became part of an immense cosmic web stretching across the observable universe. With every step, our place in the cosmos became smaller. But let's put all of those scales together one final time. Imagine shrinking Earth until it is the size of a grain of sand resting in the palm of your hand. At that scale, the Moon would orbit about 4 centimeters away. The Sun would become a sphere about 11 centimeters across, sitting roughly 12 meters from your tiny grain of sand. The entire inner solar system would fit comfortably inside a neighborhood. Neptune would orbit nearly 450 meters away. The edge of the solar system, including the distant Oort cloud, would extend for tens of kilometers. Already, our comfortable understanding of distance has completely disappeared. Now imagine shrinking the entire solar system until it fits inside a single coin. At that scale, the nearest star would still be hundreds of kilometers away. Everything humanity has ever explored with spacecraft would occupy a tiny metal disk, while the next star would be in another state or another country. Shrink the Milky Way until it becomes the size of North America. At that scale, the solar system would be smaller than a microscopic bacterium. It would be completely invisible. Now zoom out again. Imagine reducing the Milky Way to the size of a single grain of sand. The Andromeda galaxy would be another grain of sand sitting about 1 meter away. The entire local group would occupy only a small table. The observable universe, however, would stretch for several kilometers and contain hundreds of billions of these grains. Every one of them is an entire galaxy. Every galaxy contains hundreds of billions of stars. Around many of those stars are planets. Around some of those planets may be moons. And on at least one tiny planet orbiting one ordinary star inside one ordinary galaxy, a civilization evolved that became curious enough to ask how large the universe really is. Perhaps the most astonishing fact is not the size of the universe. It is that we are capable of understanding any of it at all. The atoms inside your body were forged inside ancient stars that exploded billions of years before the sun existed. The calcium in your bones, the oxygen you breathe, the iron flowing through your blood, and the carbon that forms every cell in your body were all created inside stars that died long before Earth was born. In a very real sense, you are made of the universe trying to understand itself. Carl Sagan famously said that we are star stuff. Modern astronomy has shown that this is not poetry. It is literally true. Every telescope humanity has ever built has expanded our understanding of reality. Every new generation has discovered that the universe is larger, older, and more mysterious than the generation before imagined. And yet, after centuries of discovery, one final question still remains. Does this incredible journey ever end? Throughout this documentary, we've traveled farther than any human ever will. We stood on Earth and watched our planet become a tiny blue sphere. We crossed the solar system, and discovered that it is mostly empty space. We traveled between the stars and realized that even light needs years to reach our nearest neighbor. We explored the Milky Way, then watched it become just one galaxy among billions. We crossed the observable universe itself and arrived at the greatest horizon science has ever measured. And now we arrive at the place where knowledge meets mystery. There are questions that humanity can answer. We know how stars are born. We know why galaxies form. We know that the universe is expanding. We know that it began approximately 13.8 billion years ago. But beyond those remarkable discoveries lies an ocean of unanswered questions. Is the universe infinite? If it is finite, what lies beyond it? Did our universe emerge from something even larger? Are there other universes completely disconnected from our own? Will we ever know? The truth is that no one, not even the world's greatest physicists, has definitive answers to these questions. And perhaps that is exactly what makes science so extraordinary. Science is not the collection of answers. It is the pursuit of better questions. Every generation has believed it was close to understanding everything. Every generation has been humbled by the next discovery. When people believed Earth was the center of creation, we discovered the solar system. When we thought the solar system was everything, we discovered the Milky Way. When we believed the Milky Way was the entire universe, we discovered billions of galaxies. Today, we call our map the observable universe. Who knows what future generations will call it? Perhaps centuries from now, our descendants will look back at today's understanding the same way we look back at ancient maps of a flat Earth, an important first step, but only a tiny glimpse of a much larger reality. That possibility is both humbling and inspiring. The universe does not exist on a human scale. It does not care about our lifetimes, our civilizations, or even our species. It has existed for billions of years before us and may continue for trillions of years after we are gone. Yet, despite our incredible smallness, something remarkable has happened. A collection of atoms on a small rocky planet evolved into beings capable of asking questions about the entire cosmos. Out of hundreds of billions of galaxies. Out of countless trillions of stars. Out of a universe stretching at least 93 billion light-years across. You exist. You can look into the night sky, understand what those tiny points of light truly are, and realize that every photon entering your eyes has traveled an unimaginable journey across space and time. Perhaps that is the greatest miracle of all. The universe is beyond human imagination. And yet, through curiosity, mathematics, and science, humanity has managed to understand more of it than anyone once thought possible. The more we discover, the more mysterious the universe becomes. And maybe that is the lesson this journey has been teaching us from the very beginning. The universe has never become smaller. Only our understanding of it has become larger. And somewhere, beyond the most distant galaxy we can see, beyond the horizon where light can no longer reach us, beyond everything humanity has ever observed, the story of the universe continues.